This is topic 9.6 and 9.7, ocean warming and ocean acidification. Make sure you follow along on your study guides with our learning objectives. Okay, up here, I can describe how ocean warming is altering ocean ecosystems. So bodies of water from lakes to oceans have warmed due to climate change, and lakes, of course, faster, they're shallower. The oceans have absorbed, we estimate, about 90% of the excess heat generated by anthropogenic activities. So actually our land and where we live would be a lot hotter, except the oceans have absorbed most of that heat. Thank you, oceans. Now we have, remember, range of tolerance. We learned that, and we've been talking about that all year since Unit 2. And you can see here there's an optimum range. Outside of that, you have stress, and then intolerance. You're not going to find it. So species will have to adjust. They may migrate. Down here, here's an example. Fish species in the North Sea around England, Norway, and the Netherlands have migrated due to an increase of just 2 degrees Celsius over 3 decades. So they're living in different places. So ocean warming can affect in a variety of ways, including loss of habitat, metabolic, which is how your body processes, like how your body works in terms of digestion and breathing and things, and then reproductive changes as well. Ocean warming causes coral bleaching, which occurs with the loss of algae within the coral that causes the corals to bleach white. Some corals recover and some die. Let's take a look at that here. We're going to go into the coral bleaching and some more in just a minute. First of all, you need to understand, and this is super important right here, the number one way that oceans are increasing and rising is number one, thermal expansion of water. People think it's the melting ice. That's the number 2 cause. The number 1 cause, and you need to know this for your test and your AP test, when water is warmer, the molecules are more active and they push. And that actually expands the water. It takes up more space. So warmer water takes up more space. So thermal expansion of water is the number 1 reason why ocean levels are rising. The second is the melting ice, which makes the levels higher. But again, it's a misconception out there in the regular world about which is the primary cause. Okay, economics. Sometimes in the AP test on FRQs, you're asked about economics. So we've got property loss. You can see here the ocean. This is especially during a big storm. Big storms are coming further in because there's higher water levels and causing property loss from flooded homes on the coast. Saltwater intrusion into freshwater aquifers, which costs money to remove the salt or find an alternate water source. And then specifically what causes coral to turn white, there's a algae called zooxanthellae that leaves the coral due to increased temperatures, due to more acidity or pollution. And it's the color of the algae that make the color of the coral. Coral is a little animal that has to live with algae. They're in mutualism and they need each other to survive. But the algae can't live in stressed conditions. So you can see here, healthy coral, the coral and algae depend on each other to survive. Again, coral are little animals, and it's their skeleton that you see, like if you have a piece of coral, that's their skeleton, the animal skeleton. If stressed, algae leave the coral and it's white and pretty much dead. Almost dead. It actually can recover. My cousin just went to the Great Barrier Reef in Australia, and they were talking to marine biologists there because she took a group of students, and they were saying that it's not permanent. Most of the time, coral bleaching isn't permanent. When they say the reefs are dead, it can be just temporary from a temporary dump of pollution, and a lot of times the corals recover and the algae come back. Okay, ecology. This is for nature. Loss of habitat for coral reef species, like Finding Nemo and all of those species live in the coral reefs. Loss of food source for species. Economic problems from coral bleaching. Loss of tourism money, people who go there to scuba dive, snorkel. Loss of a fish nursery, which decreases fish to catch and sell. How would a marine organism's metabolism change with warmer oceans? How could this impact the organism? It slows the organism down and they can have a hard time digesting food or escaping predation. And then it's a physical property of water that there is less dissolved oxygen in warmer waters. All right, so here we can see that's our bottom temperature has gone up in the past several years. This is the number of fish species collected in terms of fish distribution. I'm not quite sure what this one's trying to tell you, because it looks like they're collecting more. It could be because different fish are migrating. I'm not quite sure what this graph is supposed to represent, or what the point it's trying to make. All right, so as CO2 concentrations have increased in the atmosphere, the ocean acts as a sink for absorbed carbon dioxide. We've been talking about that previous to this video. What is new to this video may not be new to you. Again, in regular NGSS chemistry, we talk about ocean acidification. So you may already know that dissolved carbon in the ocean creates carbonic acid, which lowers the pH of water. So currently the pH of the ocean has been found to drop, going from about 8.2 to 8.1. Now, this may not seem like what's the big deal? That's hardly anything, except that's actually because of the way the pH scale works. It's about 25% more hydrogen ions in the water, so it is significant. Here is our equation about how ocean acidification works. You have CO2 plus water, you get carbonic acid, and it ends up creating dissolved bicarbonate pool. We'll talk about what that means in a second in terms of APES. You don't have to know the super chemistry part in our class. Okay, so ocean acidification prevents the species that build cells of calcium carbonate from doing so. So corals build their shells from calcium carbonate, which is also known as limestone. Clams, scallops, oysters, some crustaceans like crabs or crustaceans and lobster. The decrease in pH causes the calcium carbonate to dissolve. So species are either killed, as in the case of coral, or will not be able to grow as large as they used to, like sea urchins. Some species like crayfish may build thicker shells to handle lower pH and are more successful. The current pH is 8.1. The projections by the end of this century is about 7.8. That's just one estimate. Again, there's a lot of computer models and a lot of uncertainty. What's the chemical reaction? It's right here. So you can go ahead and write that in your study guide. Now, do you need to know the chemical reaction? I would say you need to be able to recognize it. You may not need to be able to write it. So in the past on the AP test, on occasion they'd ask kids to write out equations. Since the test and our curriculum was rewritten in 2019, that is probably not going to be asked anymore, but you do need to be able to recognize the equation. What prevents shellfish from making their shells? Shellfish and corals make their hard bodies mainly from calcium carbonate, which is carbonate and calcium. Since carbonate is turned into bicarbonates, shellfish cannot use these ions as well to build the shells. How does this impact coral reefs? Coral reefs are made from calcium carbonate. Let me fix that. And since there is less carbonate ions, they cannot build their reefs, which is really what their coral bodies are. What are economic consequences? We talked about this before. Here's a little more. Loss of tourism money, loss of fish nursery, which decreases the fish to catch and sell. We went over that previously. Okay, what's our solutions there? How do we fix not just ocean acidification and warming, but all of the problems with climate change? So Kyoto Protocol happened in 1997. It set a goal for global emissions of greenhouse gases by all industrialized countries to be reduced by 5.2% below their 1990 levels. Now, America didn't do it. They actually, our representatives went to Kyoto, Japan, to sign the agreement, brought it home, and Congress was like, no, we don't want to sign this. We don't think it's fair. So they didn't sign it. They thought it was not fair because developing countries who were developing their economy and getting out of poverty did not have to follow the same guidelines that developed countries had to. So it was never formally agreed to. We were the only industrialized nation not to sign. But we are reducing our levels due to increased efficiency. So the US, even though we did not sign, we have reduced our carbon levels. So that's great. Some options to curb greenhouse gases are carbon sequestration, which we talked about on a previous video, increasing fuel efficiency of our cars. In 2015, we had a new agreement in Paris. The agreement was signed by 196 nations, but it's non-binding. In other words, there's no consequence for not meeting your carbon decreases. All right, so those are what you need to know for those two topics.